So same question as before. We're given the one trig function and an information on the quadrant where the angle lies. The angle, careful, is called t here, and we need to find all other 5 trig functions. So I'm going to use the method I prefer. So in quadrant 4, we have to understand where we are. We're here, right? So this is quadrant 4. So here, if I've got a point, its x-coordinate is positive, so that means cosine is positive. I should write cosine t is positive. Cos t is positive. Sine of t is negative because the y-coordinate is negative, and tangent, which is sine over cosine, well, since the signs are opposite to one another, it's going to be negative. So let's keep that in mind. So with that in mind, I will construct a triangle, okay, ignoring the negative sign first, like in front of minus 11 over 13, and I'm going to put t here, and sine is opposite over adjacent, so I'm going to look at 11 over 13 as, sine is opposite over hypotenuse. So this is opposite over hypotenuse, and very, very quickly I'm working with a triangle with integer values for the lengths. Now I'm going to find the adjacent side. Okay, that's easy. I use the Pythagorean identity. So a squared plus 11 squared is 13 squared. So a squared is 169. That's 13 squared minus 11 squared. And that's going to give us what? It's going to give us 48. So a is, I think, the square root of 48. 48 is 16 times 3. So there's a perfect square hiding in 48. So this is going to be 4 root 3. Bingo. Okay, so I've got, okay, so now a is not of integer value, but still I can now easily calculate my other trig function. So I'm going to start with cosine. So cosine is adjacent over hypotenuse. Now careful, is it plus or minus? So cosine is positive in the 4th quadrant. So this is where I go back and look at the information I deduced. So sine is negative. So, but this I already know. Right? I already know the value of sine of t. Oh, it's not theta, it's t. Use t. Cosine. What else do I need? I need tangent. Tangent is opposite over adjacent, and tangent is negative in the 4th quadrant. So that could be my answer, but normally we rationalize the denominator, so I multiply by root 3 at the top and at the bottom. Okay. And then what? I've got, maybe I can start with this one. The 1 over cosine is secant. So secant is going to be 13 over 4 root 3. And let's rationalize the denominator. Cotangent is the reciprocal of tangent. So minus 12 over, well, actually, you know what? I'm going to flip this expression around, because doing that I will have no radical in the denominator. So minus 4 root 3 over 11. There we go. And what am I missing? I'm missing cosecant. Cosecant is the reciprocal of sine, which was given to me initially. So minus 13 over 11. So here we go. We've got them all here. So I think this method, okay, once you get used to it, is a lot faster than what they show you in the book. And that's pretty much it for this section. In the following, in this chapter, we're going to look at the graphs of sine and cosine and tangent in greater detail. And after that, we're going to move to a chapter where we'll look at trigonometric identities. So we explore a little more other identities besides the Pythagorean identity that we have seen that relate the trig functions together. And that's it for this week's material.